Hello everyone, thank you for taking the time to join us today. Let me start this presentation with a question. Did you know that Jakarta is ranked 30th as the most congested city in the world by 2023? Traffic congestion here impacts not only our time but also the environment. Each year, residents spend over 200 hours just driving. About 117 hours are lost to rush hour congestion, and it contributes to 270 kilograms of carbon emission annually. Clearly, Jakarta needs an efficient solution for managing traffic. Introducing VCA, a web-based application designed to enable real-time vehicle counting and classification with high accuracy. It's a reliable tool for traffic analytics, helping government and organizations make faster and better decisions. Our objective is clear: monitor vehicle volumes and traffic patterns, design efficient transportation policies, reduce congestion, and lower transportation-related emissions. We couldn't have done this without our dedicated team. Let me introduce you to the brilliant minds behind VCA. And here are the key features of VCA that make it stand out. User registration and activation. Simple account setup with secure OTP verification. All vehicle types capable of detecting cars, motorbikes, and trucks. Real-time vehicle counting. Display traffic data in user-friendly graphs and cards. And last, user-friendly interface. Easily analyze data by selecting specific time frames.
And the next slide is we can see a modern dashboard displaying impressive static. So in the dashboard, there are a total of 98,234 vehicles were monitored with a detailed breakdown showing 23,784 of car and 62,784 of motorcycle. So this design is a clean interface, include a convenient site and navigation menu and user management table. So all designed to facilitate efficient traffic monitoring and analysis.
This is a demo of the system we developed VCounts. The first feature is to do real-time vehicle counting, starting from the camera that will take data in real time through edge device and cameras. Then, send using the publish method through the MQTT broker. Later, the website that acts as an interface will subscribe and take vehicle counting data in real time. As seen, there is almost no latency in sending data. The second feature is to view historical data as a whole. Vehicle data will be stored in the database so that historical data can be displayed in real time via the dashboard. The data you want to see can also be accessed based on the date range entered, creating a more comprehensive and targeted data display.
In the next section, we will talk about machine learning tools that we use in this project. The first one is YOLO, or You Only Look Once. We choose this pre-trained model as it delivers results that align better with our expectation compared to the custom model that we developed. The company also prioritized a model that delivers both high accuracy and real-time processing capabilities, so we choose YOLO for the model. The second one is OpenCV library to capture video input and counting the vehicle that cross the line. The third is NumPy that used for mathematical computation. And the last is PyYarn for dataset configuration. It is used to specify dataset details, including paths, to training and validation datasets, number of classes, and their names. Next, we will talk about our dataset that we use in this project, which is COCO dataset. COCO was used because of its diversity and suitability for building an accurate and reliable object detection model capable of working in various real-world scenarios with the requirements as targeted by the YOLO model. The class that we use are four, which is car, truck, bus, and motorcycle.
Let me continue with the model we use. The first one, pretend YOLO model. YOLO is pretend on large datasets like COCO, which include thousands of labeled images with bounding boxes and class annotation. Next, model loading. The pretend model is loaded using libraries like Torch, and we configure it to focus on specific vehicle classes using classes 2, 3, 5, and 7 corresponding to cars, motorcycle, buses, and trucks. Next, object detection. YOLO divides the image into grids and detects bounding boxes to locate the object, class labels to classify objects, and confidence scores to indicate the detection accuracy. Next, object tracking and counting. Each detected object will get unique IDs for tracking, and when a vehicle center processes the red line, the system will update the count or its class. Next, performance metrics. Since we are using YOLO 11N, this is the performance metrics of that. The first one is mean average precision of or MAP to measure accuracy, and our model achieved 39.5%. Next parameters, we got 2.6 million. It means 2.6 million trainable parameters, and it is a lightweight and efficient. Next, floops or floating points operations, we got 6.5 billion. It requires 6.5 billion calculation P per forward pass, balancing performance and efficiency. And this is the result of machine learning system in action. Vehicle are tracked using unique IDs, which ensure each detected object is identifiable across frames. They are then classified into various categories such as cars, motorbikes, trucks, and buses. Additionally, when a vehicle crosses the red line, the system will count the crossing event and updating the count for the respective classes in real time.
This slide highlights the tech stack used in our vehicle counter. At the core, we use Google Cloud Platform for hosting and managing our service. The backend is built with Node.js and Express.js for handling APIs, while the front end is developed using React.js. For styling, we use Tailwind CSS, ensuring a clean and responsive design. Data is stored and managed using Firebase for real-time updates. We also use Docker for containerization to streamline deployments, Git for version control, and Superbase for additional database functionalities. This tech ensures scalability, efficiency, and a modern development workflow. Our architecture starts with edge device running counting models. Data is sent to MQTT broker on compute engine, then processed by the backend on Putra, while the front end on Putra display the result. Cloud SQL handle authentication and file stores machine learning data. This setup ensures efficiency and real-time processing. Why we are using Putra for our deployment? First, it's cost efficient, as you only pay for what you use. Second, it offers automatic scaling, which adjusts resources dynamically based on demand, ensuring efficiency. Third, it enables fast deployment, allowing us to quickly roll out updates. Finally, it provides automatic SSL, ensuring secure connection without manual configuration. These features make Cloudrun an ideal choice for our cloud-based application. For real-time communication, we use MQTT, a lightweight protocol with a publish-subscribe model. Each device sends data to an MQTT broker, and the backend receives it in real time using publish-subscribe schema. Its key advantages are low latency, lightweight nature, PubSub, and reliable and efficiency in constrained networks.
And now I'm excited to present the next slide regarding existing result. And in this table, we compare the traffic management system here and Margaretha system and our system Vital, highlighting their key features. This comparison show that while both solutions are advanced, but Vital focuses on leveraging deep learning and providing a scalable, adaptable, and user-friendly system. And having established our technological advantage, the next step is to connect with stakeholders effectively. Firstly, we plan to partner with the government to offer IoT and machine learning-based traffic management solution. And next, conducting digital marketing using platform for promotion. And thirdly, participating in transportation and technology conferences to introduce this project. And lastly, publishing a success report from the initial implementation to attract interest from other target market. And the next slide is our target market is firstly local and national government. They need accurate traffic data to support infrastructure planning and improve public transportation. And secondly, toll road operators need accurate vehicle monitoring to optimize traffic management. And with real-time traffic data, these companies can plan more efficient routes and reduce operational costs. And lastly, for better urban planning and understanding the needs of our target market is critical, like efficiency, accuracy, real-time monitoring, and scalability. And the next slide is our implementation schedule for the next 6 months. And then for the next slide, this is the result of our project SWOT analysis, and this is our strength, our weaknesses, our opportunities, and our threats. This will provide insight into our position in the market and the step we can take to mitigate risk. And for the next slide is the link to our project GitHub documentation. And finally, thank you very much for listening to our presentation. It's all from us, and we appreciate your time and your attention.